I'm going to solve a rational function and graphing it. So the function is x squared minus 3x over x squared minus 11x plus 24. So the first step is to find the horizontal asymptote. How can you find the horizontal asymptote? The horizontal asymptote is by the aspect of the exponents. So the exponent, if the exponent of the numerator is less than the exponent of the denominator, the horizontal asymptote is going to equal to 0. But if the exponents are equal to each other, the horizontal asymptote will equal to its division. So here we can see that the exponent from the numerator is 2 and from the denominator is 2 also. So it's going to be equal to. So it will be 2 over 2, which will equal to y is equal to 1. So that will be our horizontal asymptote. Y is equal to 1. So y-intercept, you have to equal x to 0. So equaling x to 0 will give us 0 over 24. And we all know that a fraction that its denominator is 0 will equal to 0. So our y-intercept will be 0, 0. So now we're going to register it here. Y-intercept 0, 0. So now we have to find the domain. The domain is found by factoring the equation. So the factoring will result to x times x minus 3 over x minus 3 times x minus 8. So to find the domain, we just have to look at the factored denominator and equal these to 0. So x minus 3 is equal to 0. So it will be x is equal to 3. And here x minus 8 is equal to 0. So it will be x is equal to 0. To 8, sorry. So our domain will be x such that x is not equal to 3 and it's not equal to 8. So now we'll register here. The domain is not equal to 3 and 8. And now we have to find a hole or holes if there are any. So find if there are any holes, we have to look at the factored equation and see if there are any equal expressions in the numerator and the denominator. So here we see that there are both x minus 3 and x minus 3 in the numerator and denominator. So what we're going to do is erase them from the equation. X minus 3 and x minus 3. What we're left off is with x over x minus 8. So now we have to substitute the expression that we eliminated. So the expression that we eliminated was x minus 3. So we equal that to 0, which will give us x is equal to 3. So now we substitute 3 in this equation. So it's 3 over 3 minus 8, which will result minus 3 3/5. So our point in the graph, the hole will be in 3, comma, minus 3/5. Now we will register it here. There is a hole in 3, comma, minus 3/5. So now we have to find the vertical asymptote. To find it, we have to look at the equation with the factored and without any holes, and we have to equal the denominator by 0. So it will be x minus 8 is equal to 0. So this will result to x is equal to 8. So our vertical asymptote will be x is equal to 8. So we have to, now we register it here, x is equal to 8. Now we have to find the x-intercepts. Now to find the x-intercept, we have to, instead of looking at the denominator, now we have to look at the numerator. So it's x, so it will be equal to 0. So our x-intercept will be 0, 0. Now to have more complete our information and then to graph it, we have to substitute some values to have extra points in the graph. Now I use numbers that are close to the vertical asymptote so I can get a closer view of how the graph is going to behave. So I used 7 and 9, which are close to 8. So when I substitute x over 7, it will be 28 over minus 4, which will equal to minus 7. So 1 point will be 7, comma, minus 7. And when you substitute x over 9, it will result into 54 over 6, which will give us 9. And the point will be in the graph 9, 9. So now I'm going to register it. 7, minus 7, and 9, 9. Finally, we have to graph our function. So first we have to put the horizontal asymptote, which is y equals 1. Here it is. Now we have to put the y-intercept, which will be 0, 0 here. And now the holes, which will be approximately over here. Now we have to put the vertical asymptote, which will be 2, 4, 6, 8, which each unit is equal to 2, which will be 2, 4, 6, 8 here. Next, we have to put the x-intercepts, but here it's 0, 0 as the y-intercept, so we don't have to put another point there. And finally, we have to point the points that we did extra so that we kind of could know how the graph is going to react. So, behave, sorry. So it will be 7, comma, minus 7. Approximately over here. And 9, comma 9. Which will be approximately here. So now we can see how the graph is going to behave. So now we just draw it. It's not exact, but it gives us an idea of how it's going to behave. And like this. So that's our graph and our results of each point.